Okay, for chapter 11, we're talking about displaying distributions with graphs. For this first part, I'm going to break this one up into two videos. For this first video, we're going to talk about creating and understanding histograms. So from chapter 10, you remember that we did like pie charts and bar charts. So those are good for categorical variables or variables that split it into categories. But what about variables that are quantitative, such as SAT scores, or of students admitted into college, or the income from individuals? Because those are quantitative, it's hard to make a bar graph or a pie chart out of those. So we're going to do a histogram. A histogram represents the distribution. So the way the variables, the quantitative variables, the way the numbers are spread out, basically. Okay, for our first example, we're going to make a histogram of the data in this table. So this table, table 11.1, shows the percent of the residents that are 65 years or older in each of the 50 states. So like you can see, if we can find Ohio, so here's Ohio, 14.1% of our residents are 65 or older. Now, before I switch slides, what I want us to see, can you figure out which one is the has the least percent and which one has the highest percent? So yeah, least should be, let's see, Alaska with 7.7%, and then the highest is going to be Florida with 17.3%. So we're going to use those on our next slide. All right, to make a histogram, our first step is going to be to divide the range of the data into equal classes of equal width. So on a previous slide, we found that the range ran from a 7.7 to a 17.3%. So why don't we make classes going by just kind of one unit? So starting with the 7, so we're going to have everybody that's between 7.0 and 8.0. That's going to be our first class. Then we're going to go from 8.0 to 9, from 9 to 10, from 10, 10.0 to 11. Fix these up real quick. Then from 11.0 to 12, 12.0 to 13, 13 to 14, 14 to 15. Messed up with this one. 15 to 16, 16 to 17, and we have to go up to 17.3, so let's go 17 to 18. Now I added the 0.0 because, we're all dealing with decimals, so might as well add the 0.0 for all the decimals to keep that decimal point consistent. So you notice I put all of these into interval notation. So interval notation means when you're using the bracket, you have it can equal the number. So like if we look for our first interval there, it's anything between 7 and 8. So it can equal 7. The parenthesis means it can't equal, so it can't equal 8. So, but look at the next column, the next interval. The next interval, it can equal 8, but it can't reach 9. But the next one, it goes from 9 up to 10, but not reaching 10. Then it goes from 10, where it is 10, up to 11, but doesn't reach 11, and then so forth. The reason is this last sentence right here. Be sure to specify the classes precisely so that each individual falls into exactly one class. If you got a data value that's going into two intervals there, you got to fix it because that's going to be a problem. It has to go into one interval, one different class, or one individual class. All right, once you have your intervals, you're going to go on to step 2, is where you're going to count the number of individuals in each class. So the textbook here, we already have the counts for us. These came from that chart at the beginning of the slide. So where it listed each state. So if you're looking at like right here where it says from 10.9 to 10.0 to 10.9. There were 3 states in that category. So 3 states had between 10 and 10.9% of their individuals who were 65 or older. And let's see, we said Ohio was 14 point something. So Ohio would be one of these 12 in here. All right, next, step 3 is you draw the histogram, which actually I have it on the next slide, but kind of some different things on here. Basically, you mark your horizontal axis, your x-axis. That's going to be your scale for the whatever it is that you're displaying, the numerical values. So in our case, it's going to be the percent of the residents. So you can kind of look at it. So our scale down here is going to be the percent. And then the count is going to be the vertical axis. So it's going to be count this way. So like we said, that there were 3 states that were between 10 and 10.9. So for our percent down here, let's say if this was our 10.0 to 10.9% right here, it would go up to bar 3. Each bar, which I'll show you in the next slide, each bar is going to represent the class. The base of the bar covers the class, and the bar height is the count. So these are where all your bars are going to like touch each other. They're right next to each other. There's no space between them. Bar graphs, there were space between them. Histograms, there are not. They're right on top of each other. And then unless, this kind of last line there, there's no horizontal space between them, so the bars touch each other, unless a class is empty. If it's empty, there's no count there, so then you can leave a space. So here it shows the histogram and kind of shows what I was talking about on the previous slide. So down at the bottom, you see that that's where we have our percentage, and then we have our number of states, or the count that we found from our kind of the chart that we kind of just did in step 2. So you see all the bars are right on top of each other. You know, there's no space between them except for the space between 8 and 9. That meant that there were no states that had between 8 and 9% of their residents who were 65 and older. So no states were in that range. You can see where most of the states were up here between 13 and kind of this column right here, between 13 and 14%, or 13 and 13.9%. That had the most states in that category. We kind of look at this graph and say that it is symmetrical. Now, when we say like symmetrical, if we look here kind of where this kind of top part would be, we kind of notice that the bars are kind of similar there, they're similar there, they're still kind of similar on either side, on the left side and the right side. So like they're kind of symmetrical would be if you've got that center point in the middle, your bars on either side go down pretty similar. So this would be kind of like a little symmetrical sketch there. They don't have to be exact, but they're similar. So like this black line would be kind of like your mirror line. So it's symmetrical across the kind of that top bar there. Now, some things to consider. So the classes for histogram should have equal widths. You should choose the number of classes carefully. Usually it's recommended between 10 and 20 classes, but if you have a small data set, then you can use smaller size classes or a smaller amount of classes. Often you see if we have too few classes, let's say we only had like 3 classes, we would have what they would call a skyscraper histogram, which if I can do a little sketch down here, here's my axes. A skyscraper would have just lots of like tall, tall, or not lots of, you would only have like a few tall bars because most of your data will be in that because you only used a few classes. If you use too many classes, that would be a pancake type of graph, which your pancake would look like this. It would just kind of be all really small, really kind of all the same, spread out. They should be the same width, and mine are not. But they'd all be very similar, so they're flattened down. So think of too few classes will give you that skyscraper where all the values are clumped together and kind of all about the same height and pretty tall. like, tall like skyscrapers. But then your pancake graph, all of it would be kind of flattened out and kind of pushed down, similar just like a pancake. Now, after you look at a graph, you want to always ask, what do I see? In any of the graph, you're looking for two things typically. You're looking for overall pattern, and you're looking for striking deviations from that pattern. So the histogram that we made for the percent of residents that were 65 and older in the states, that we saw that two states kind of stood out. So Alaska and Florida kind of stood out as either really small or really tall percent of its residents, or small values. These are what we call outliers. And an outlier is, in any graph of the data, it's the individual observation that falls outside the overall pattern of the graph. So numbers that are really big or really small compared to the rest of the data. We also want to look at the overall pattern of a histogram, or like the overall trend, and this is ignoring the outliers. So we're kind of, the outliers are a separate thing, but the bulk of the data without the outliers, what are the trends that we see? What are the patterns? So we want to look for the center, and when we look for the center, we look at where the midpoint is. And to find the midpoint, it's going to be your large number minus the smallest divided by 2. That gives you your midpoint. The variability, that is the spread of your data, or the range. And the shape we're actually going to talk about the next slide, but the shape will be things like, is it symmetric? Is it skewed left? Is it skewed right? So let's see, shape. We'll add that on here. Symmetric, skewed left, or skewed right. So looking at our example, the shape, we kind of talked about it, it's symmetric. It has kind of this single peak up here, and it's roughly symmetrical. So that is, the pattern is similar on both sides of that peak. The midpoint, which they just did an approximate, but you can see where the middle of the data is right there at about 13%. And then the variability, so, not including the outliers, we go from about 9 to 18. And I know we kind of said 17.3 was the outlier, which they kind of did for this one. Honestly, I wouldn't include it. I would have said maybe the 7, but the bulk of our data goes from 9 to 8. So that's where there's like no spaces in between. 9 to 18, sorry. That's where there's no spaces. So the different shapes of a histogram, it can be symmetric, which is if the right and the left sides of each other are mirror images of each other, approximately mirror images. The skewed to the left distribution is skewed to the left if the right side of the histogram extends much farther than on the left side. So what I like to say, it is, on this case, it's kind of weird. The data is going to be, taller on the left. And then if it is skewed to the left side, it's going to be taller on the right. Kind of where like well, I'll show you an example. All right, these two charts are going to be skewed left, which seems weird because the bulk of the data is on the right side. But all these numbers, it's smaller on the left. So like it extends further, your tail extends further on your left. So if you kind of drew that curve over your data, just like I did in these two, you see that our tail would go to the left side. So it's skewed left. If it was skewed right, I'll draw a little picture up here in the corner. Skewed right would look like this, where you'd have most of your data up here on the left-hand side, and then your tail will kind of go. So like this would be an example of skewed right.